Our last video went over the structure of XML data and a little bit of the motivation for using XML data. It's another web data type, and we need to be able to access information within XML data. Most notably, we need to get to the data itself, which is in the leaves of the tree, and it's highlighted here in yellow. There's a Python library for everything, and in our case we want to use a library called lxml. Like many other things, I'm not an expert on this particular library, but I did look up a few things that I thought would be useful for us to go over in regards to reading and traversing an XML tree. So let's assume we have some data from a file or a website and we import it as data string. So it's in this block right here. I'm going to go ahead and run this. I'm defining this bookstore data as data string. The 3 quotation marks just mean I want to preserve the structure of this data. So it will be read as a string, but it's preserving this structure that's unique to XML. And scroll down. So now I have that data saved as data string. Now this part can be a little bit complex. What we need to do is first read in a module called etree, stands for element tree, from the lxml library. So etree is going to help us extract the structure of our XML data and preserve it as an object. So I'm going to be using a specific function called XML, which is a function that is part of the etree module. I'm going to define the root as the etree.xml, and then my argument is the data that I defined, the data string. And just to be sure everything worked, I can print the root tag. So the root tag should be bookstore, because that's the name of the root for this XML data. If I want to look at the entire object, it's going to look just the way it did when we defined it, but it will be decoded using our UTF-8. I had to look that up. So once we have gone through these first steps here of reading in our XML data, we can now work with it using some of the tools from the etree module. If I want to extract all of the elements in a tree, I can use something called the iterator, which is part of the standard library in Python. And we'll use this from time to time. The iterator traverses one complete branch of the tree and then comes back up one level and traverses the next branch. So what does that mean? That means it's what's called a depth first search. You don't need to memorize that, but maybe just hear the term and know that it describes this pattern. We start with bookstore, we go to book, we go to title. We would then go back to book, and then we would move to authors, author, first name, and we could actually get the text from that leaf. Then we're going back a level to author, and then to last name. And then we've traveled through all of the branches under this first book, so we're going to have to go back to where we first branched off, and we'll go to the other book and traverse that path in the same way. So the iterator helps us do that, and here's how we could use the iterator as part of a for loop. So I could just define something called element. I'm making up this term. For element in root is our object that we defined. For element in root.iter, print the element. And what this is going to do is print all of the elements in the tree in the order they were traversed. Another thing I could do is I could say for a child in a subtree, I could print the child. So I'm just going to do this for the root. The root is the bookstore, and it has what some would refer to as two child elements. So the parent-child relationship describes how adjacent elements in a tree are associated. So that the top level is going to be the parent, and then the two children of that parent would be the two books. So bookstore as a parent has two children, two books. The book could then be called the parent of title and authors. And the same association exists as we traverse the rest of the tree. So we can use this just to print the two child elements for the bookstore, and it's going to give us the books. These strings of characters are memory locations, and that's a little beyond the scope of our class. This is just an example to show I could do the same thing and just print the tag. It's a little more readable. I don't necessarily need all of that extra information. Okay, just two more things I looked up that we could try with iter. I'm not sure how to pronounce that. We can use the iterator function to get specific tags. In the example below, we're only going to specify the tags called author. For each author tag, we're going to use the find function to access the first name and the last name tags. And notice the .find is only going to look at the children of author. So author has two children, first name and last name, no other descendants. The .text here is going to actually give us the data in that node or in that element. So I'm going to say for element in root.iter, and the author is now the argument. So I want to only look at that one particular element. And I'm going to print the element. I'm going to find the first name, and I'm going to access the text associated with the first name. And here I have all the names of the authors in this data structure. One final thing we could do is we can access elements based on a specific attribute. For example, if I want the title of a book that has a specific attribute, say ISBN number, I could use this code. I could say book, and then I could use the square brackets to select. And then here, this ampersand is saying this is this is how I want to make my selection. I want the ISBN number equal to this value that I provide. And it looks like this in one whole command. So print the root.find the book with this ISBN number, get the title, and give me the text associated with that title. And here's an exercise that I have already done for us. If I wanted to access the last name of the author who wrote the book that weighs 1.5 units, not the most useful information, I would use this pattern. I would use root.find, and then the book with the specific attribute, and then here I'm traversing through the tree. I'm making that specific specification of weight for a book, but then I want to traverse all the way down to the last name. So I use these forward slashes to create the path, and then I get the text associated with that last name. So those are some things we can do with XML data. There is a lot more we can do, and you're welcome to look it up in some of these links that I've provided. But that's all we're going to work on with XML for now.